Okay, so the lessons on multiplying rational expressions, you guys will remember a rational expression is where you have a numerator and a denominator, and both of them have actual expressions. I want to take you back to grade 9 for a second. Do you guys remember when we used to do questions like this? 2 over 3 times 9 over 4. And do you remember how we taught you how to cross reduce? Yeah, so cross reducing is when you have two fractions and a multiplication sign in between them, and you can take something from a numerator and something from a denominator, and you can reduce them as much as possible. So for example, 2 and 4 will become 1 and 2, 3 and 9 will become 1 and 3. Okay, that sounds familiar, right? Perfect. So we're actually going to be using a similar concept when we're multiplying rational expressions, except now we can cross out entire letters and binomials, just like yesterday. So take a look at the notes here. If the problem contains just monomials, then we're going to multiply everything together and then simplify. If it contains binomials and trinomials, we'll factor everything and then simplify. So just like before, it's overkill. We're just going to do one side. How about we do, we'll start with example 1 and then maybe just do the left side. So in this example, I have a monomial divided by a monomial times a monomial over another one. The first thing I'm going to do is I'm going to use my exponent laws, and I'm going to combine everything in the numerator and combine everything in the denominator. So what's that going to look like? Well, 10 times there's no other number, so it's just going to be a 10. I have a to the power of 3 and a squared. What's that going to become? Good, a to the power of 5. Then I have b and b. That'll just become b squared. Remember, you're just adding the exponents. And then I don't have a c, but I have another c there, so I'll just include that. And I have a d, and I don't have a d there, so I'll just include that. So if you don't have a matching pair of letters, that means you just include everything. Okay, now the denominator, 5 times 4 is 20. A times nothing is just a. B squared times nothing is b squared. And then we have a c, and then we have a d. Now, remembering our exponent rules, 10 divided by 20 was just going to be 1 over 2. A to the power of 5 divided by a is going to be a to the power of 4, but is it going to go in the numerator or denominator? Good, so it's going to be a to the power of 4. How about b squared and b squared? It'll just cancel out. How about c squared and c? C at the top. And how about d and d? It's just going to cancel out. Cream, question? Can we reduce in the beginning? You could have done that as well. Like canceled out the 10 and the 5 and then the 2 and the 4. Yeah. So overall, this is going to be a to the power of 4 times c divided by 2. I'm just going to rewrite that so it doesn't look so obnoxious. So it's just, what did I say? A to the power of 4 times c all over the number 2. Oh, the fumes. Okay, we're just going to power through this. So let's just keep going. Question number 2. I'll skip example number 2. Let's go to question number 2 on this side. Oh, by the way, we have to do our restrictions. So remember, restrictions are anything that make the question, the denominator 0, so it's undefined. And in a question like this, where we're not really crossing out anything, we're going to state the restrictions for the very first original term. So in this question, what do you think are the restrictions? For A, B, C, and D, what can't it be? They can't equal to 0. Yeah, so we're just going to write down A can't equal to 0, B can't equal to 0, C can't equal to 0, and D cannot equal to 0. All right, looking at these questions, 1, 2, 3, 4 all seem similar. So let's go ahead and try question number 4. Again, for question number 4, you could cross reduce. So I like Kareem's idea of cross reducing. I can reduce the 3 and the 3 to make it a 1 and a 1. I can cross reduce the 2 and the 4 to make it a 1 and a 2. So if you wanted to do that, you could, and then you would have simplified numbers. If you did not want to do that, what you could do is you could just multiply everything in the top and bottom and solve that way. So if you were going that route, you would get 6. X to the power of 3, y to the power of 2, all over 12 x squared, y squared. And our final answer would just be, well, the x cubed and x squared, you'd have an x at the top, the y squareds would cancel out, you'd have a 2 at the bottom. So it would just be x over 2. And just like before, the restrictions would be x cannot equal to 0 and y cannot equal to 0. So x can't equal to 0 and y cannot equal to 0. Okay, we're going to get to the funner questions in a second. Anyone have any questions about this? It's pretty similar to what we were doing in last class. Nothing too new, right? Yep. Yep, you could have done that as well. Yeah. Okay, let's try question number 6. So now in question number 6, we can't just cross things out because you have actual binomials. So what we're going to do is, just like yesterday, we're going to go ahead and factor every single thing that we possibly can. So I see a difference of squares in the numerator, a difference of squares in the denominator. I'm going to factor those. And on the other side, I can't really do anything to those, so I'm just going to write it down as is. So I guess the rule is whenever you have binomials, you're going to factor. Yeah. All right, so when you have a rational expression times a rational expression, you can actually cross things out across the multiplication sign. So this is where, again, it's super satisfying. What I'm going to do is I am going to cross out the matching pairs. So I have an x plus 2 here and an x plus 2 there, an x minus 4 there and an x minus 4 there. That's it. That's the only different part about this lesson. This time, it's not just one fraction. It will be a multiplication sign and another one, and you can cross things out across the multiplication sign. So what will you be left with? You're going to be left with x plus 4 in the numerator and then x minus 2 in the denominator. What would our restrictions be for this question? For you? Yep, -2, 2, and +4. Because we look at this step when we're trying to figure out our restrictions, the step before we're crossing anything out. Okay, let's turn to the next page for some more challenging questions. Maybe we'll do 3 or 4 more examples and we'll call it a day. There's nothing really very challenging. Let's try question. Okay, we're going to do question 16. And of course, a challenging question is just one where you have to factor a lot. So question 16, we have a simple trinomial over a difference of squares and another simple trinomial on another simple trinomial. So lots of practice with simple trinomials. Go ahead and try it.
Did you see it, Miss Aslam?
Oh, okay. I can't do anything about it now. So hold on, let me pause. Okay, so I guess I'm gonna have B and a B and -6 plus 4 over You guys, can I ask you a question? Are you allowed to cross reduce a numerator and a numerator? How about a denominator and a denominator? Yeah, you're right. How about something in the same fraction? Can I cross reduce there? Yes. And how about something in between 2 fractions? Can I cross reduce there? Yes. So we can actually go across the multiplication sign and cross out anything we want to. So I got the following. I won't read it out loud. Let's see what we can cross out. The best part about these questions: b minus 6 and b minus 6, b plus 6 and b plus 6, and then b plus 4 and b plus 4. So we should be left with just b minus 1 at the top and b minus 2 at the bottom. B cannot equal to, I cross things out. So negative 6, positive 6, negative 4, and positive 2. So negative 6 will go first, then negative 4, then 2, and then 6. And last question, and I think that's pretty good practice. They're all pretty much similar. Let's go ahead and try 20. Okay. Yeah, 20 is a good one. So let's do 20 and then that's good. So we have a complex trinomial over just the greatest common factor. We can't, and then you can't factor 3y minus 1 and another greatest common factor. Are you guys all factored out that now you're just like, whatever, this can wait? Okay, so that's what I ended up getting. Let's see what I can cross out. There's a 3y minus 1 and a 3y minus 1, 3y minus 4 and a 3y minus 4. Unfortunately, you can't do anything with the stuff in the denominator, so we're just gonna have to multiply it out. So we're gonna end up getting y minus 1 over 20 y to the power of 3. And for our restrictions, oh, this one's interesting. So what are the restrictions in this question? There's going to be some fractions and an interesting one. Name one of them. Name one of the restrictions. So y cannot equal positive 1 over 3, Niloy? Yeah, and? Yep, and? Good. So it can't equal 0, 1 over 3, and 4 over 3. Okay, let's try another question from 1, 2, 3, and 4 are very similar. So let's go ahead and try, do you guys have a preference? No? So let's do question 2. Question 2 is good. Okay, so again, if you wanted to cross reduce, you can. I'm going to just multiply, because the numbers are pretty small, so I'm going to multiply everything in the numerator and everything in the denominator. 3 times 4 is 12. And then we have x squared and a y squared. There's nothing matching there, so we're going to have to write both of those out. X squared, y squared. 2 times 9 is 18. And then we just have a y. I can reduce 12 and 18 by dividing both of them by 6. So I'll get 2 over 3. And then x squared divided by nothing is going to keep an x squared at the top, and y squared divided by y will keep a y at the top. So I'll end up getting 2x squared y over 3. Okay, and then when I'm stating the restrictions, I just look at the denominator, in this case, just the original one, because we didn't really factor anything out. And the only restriction is that y cannot equal to 0. Because if you made y 0, then the denominator would be 0, and then the whole thing would be undefined, which is what we don't want to happen. I do feel this is very similar to last day's work. So we're actually not going to do too many examples. We'll probably do 5 or 6 and you'll get the hang, you'll start to see the pattern. Marzu? Yeah, so remember how I kept saying you always look at the step when you factored everything? In a question where you're not factoring anything, you would just look at the original question. But if you had a question where you're factoring things, then you look at the step where you finish factoring everything. Bea? Well, if x is equal to 0, that means that numerator is a 0. Is that illegal? Are you allowed to have a 0 numerator? Yes, you are. And so we don't, like, you can have x to be 0 and it won't matter. It's still valid and it's still an answer. Exactly. So all I'm doing is I'm looking at the denominator. Any other questions? All right, let's keep going. Let's try, we're going to get into something fun. So let's try question number 5. Okay, so question number 5, we have a difference of squares over a greatest common factor, a simple trinomial over another simple trinomial. I'll pause here. Go ahead and factor everything. This is great practice for your quiz. Do you guys get what I got? Okay, so now here is a new step that we didn't do yesterday. In yesterday's class, we just had one of these, right? We would just have a numerator and a denominator. In today's class, we have a fraction times another fraction, but really the concept is the same. You can find a matching pair in any part of the numerator and any part of the denominator and cross them out. For example, I have a c minus 7 and a c minus 7. Those are in 2 different rationals. Then I have a c plus 3 and c plus 3 in the same rational expression. And then I have a c minus 1 and a c minus 1 in 2 different places. As long as there's a multiplication sign, this is allowed. So we're going to be left with just a c plus 1 over 2 as our answer. And what do you think is the restriction? Where do I find the restriction and what are the numbers for it? So you're not going to go to the original question for this. You're going to go to the step where you factored everything because it's easiest that way. And you're basically going to look at every single bracket. So here it's going to be c cannot equal to 7. Here c cannot equal to negative 3. And here c cannot equal to 1. I can't see what I crossed out, but it should be a 1. Right? Yes. So it's going to be negative 3, 1, and 7 as our restriction. Does that make sense? Question? Okay, let's do, and you know what, that's actually the whole idea, but just to give you guys extra practice with factoring, we'll go to the next page and do maybe 2 or 3 more questions. And let's pick something where the factoring is a little bit, so let's do 17, 18, 19. I think that'll be really good practice for you guys. So let's start with question 17. So we have a greatest common factor over a simple trinomial over just a monomial. We're trying 17. Okay, so I factored it and I got all that stuff in the blue. Now I'm going to start cross reducing and seeing what I can cross out. So n minus 5 and n minus 5 is gone. And then I have an n minus 4 and an n minus 4. I also have a couple of monomials. Question? Why 4n squared can't be 2n squared? Do you mean like 2 times 2n squared? Yeah, you could, you can't really factor a monomial. You could split it up, sure. Yeah, you could do that just so that you can have the 2n by itself. I see what you're saying. So you're saying you prefer to write the 4n squared as 2n times 2n? You can definitely do that. Yes. If you didn't do that, that's fine. You can just cross out the 2 and make it a 1 and cross out this 4 and make it a 2. And then the n here and the n squared there is just crossed out. Okay, so what am I left with? In the numerator, I just have my n minus 4. And in the denominator, I just have a 2 times n. Does anyone want to tell me the restrictions? Two of them are pretty easy. Sarah? You're very close. Just watch your signs. If you put in a -5 in the first bracket, you get negative. Yeah. Go ahead. You got it. So n cannot equal 0, 4, and 5. Good job. Did I say 18? I feel like 18 is more of the same stuff. Is there anything different? I guess they're all the same. There are no more complex trinomials. So let's do 19, and then 20 is already done, but we haven't done it together. So we'll do 20 because that one was a little bit challenging. So let's do 19 first. So we have a difference of squares. Sorry, greatest common factor. And then we have a complex trinomial. Perfect. So let's go ahead and cross things out. So can we get like a nice something? Let's get something like that. That's good. All right. So 5k plus 1 and 5k plus 1, k plus 4 and k plus 4. So all we're going to be left with, oh, and 2 and 2 can cross out as well. So all we're left with is actually k plus 2. What is, and I just realized my color coding is all off because these guys are throwing me off. Okay, so what are the restrictions here, you guys? K cannot equal, Noel? You got -4, right? 0 is not one of them. Look at the bracket 5k plus 1. What do you think that would be? Not quite -1, Janitza? It would be -1 over 5. And I'll actually show my work for that. So I'm going to go to the side and it's going to be 5k plus 1 cannot equal to 0. 5k cannot equal to -1. And then you divide both sides by 5. And so k cannot equal to -1 over 5. Does that make more sense? Yeah. Okay. Go ahead and try question 20 yourselves and the solutions there. I like that one because it has another complex trinomial, which I feel are missing. And I'll just do 18 while you do 20 in case you want to look at that one as well. And this is going to be our last question. 20. Do you guys hear these guys planning their route of travel? Also, I noticed their group is growing. They started with 1 and now they had 3. Everyone's dropping clearly. What a fun question. Chat. Hiba, you got it right.
have a question.
Yes.
So, like in my class, we use the method where, that rainbow kind of method.
Okay, so the restrictions for question 18 were -4, -3. Yep, and then the homework is just the other 2 pages. So I'm just gonna stop the recording.